here we have to evaluate this integral I equals to x cube dy dz plus x square y dz dx plus x square z dx dy, where S is the closed surface bounded by the plane z equal to 0, z equal to b. This is your z equal to 0. This is plane z equal to 0. This is z equal to b, and the curved surface cylinder x square plus y square equal to a square. So here we have to evaluate this integral. See, I told you earlier that NDS can be written as dy dz I plus dx dz j plus dx dy k, right? So this integral I can be written as a surface integral of x cube I plus x square yj plus x square z k dot nds. So this is your function. This is the function f, and this can be written as f dot nds. Now here I can apply Gauss divergence theorem. This is a closed surface consisting of the curved surface and the two bases. So this will convert to a volume integral using the Gauss divergence theorem. d tau in Cartesian can be written as dx dy dz. So what is del dot f? You can find del dot f. Del dot f will be 3x square plus x square plus x square comes out to be 5x square dz dx dy. I have written dz dx dy because I want to first integrate with respect to z. So with respect to z I will integrate. It will be 0 to b. So this comes out to be 4b x square dx dy. We have integrated with respect to z. So the triple integral converts to the double integral. Now the domain of this double integral will be the projection of this whole solid on xy plane. So this will be something like this. This will be the domain of double integral. So now this is the domain. Domain is basically area bounded by the circle x square plus y square equals to a square. Now I can convert this to polar coordinate. Remember, wherever you are given this kind of region, it's always easier to do the integration by converting into polar coordinates. So this converts to r square in polar coordinate. In a plane polar coordinate, x is r cos theta, so x square will be r cos square theta, and this dx dy will be r dr d theta. R will vary from 0 to a and theta will vary from 0 to 2 pi. So I have to integrate this. I will wrap this portion. It will be, so this integration comes to be 5b. First of all, I will integrate with respect to r. This is r cube dr. So it comes to be r4 by 4. This is cos square theta d theta 0 to, and you have r4 by 4, and the limit says from 0 to a. So this comes out to be 5 a4b upon 4 0 to 2 pi cos square theta d theta. And you know this is a very famous integral. You can use gamma function also. This integral is pi. So it is 5 pi a4b upon 4. So this is how this can be done. Now we will move on to next problem. Now let's see this problem. Evaluate the surface integral of f over the entire surface of the region above xy plane bounded by the cone z square equals to x square plus y square and the plane z equals to 3. If f is 4xzi plus xyz square j plus 3zk. First of all, let us draw this cone and this plane and get the idea of the region. We have to use over here Gauss divergence theorem. This is a chapter on Gauss divergence theorem. We will use it we use Gauss divergence theorem to evaluate this surface integral. So let's first draw the cone. So we have drawn this cone. This is your x, y, z axis. See, this angle is 45. It doesn't look 45. You accept it. This is 45 degree because this is semi-vertical angle is 45 degree. This is 45 degree. So this is the cone. This is the cone we are talking of. This is the cone z square equals to x square plus y square. This is the upper half of the cone, and this is the plane z equals to 3. Alright. So we have to evaluate the surface integral on this surface consisting of the conical part and this planar part base. Here we will be using Gauss divergence theorem, which says the surface integral of a function over a closed surface, this is vector sign, is equal to the volume integral of f over the region enclosed by it. This is the region enclosed by it. We will have to calculate the volume integral in this region. So what is del dot f? If we calculate del dot f, this is your f, becomes 4 theta is dx dy dz in Cartesian. So del dot f is 4z plus xz square plus 3 dz dx dy. I want to integrate first with respect to z, so I have to dz over here, and the limit of z will be, you draw an arrow parallel to z axis and see where it cuts. It cut at first the cone, so lower limit of z will be under root x square plus y square, and the upper limit of z will be z equal to 3. So this is x square plus y square to z equals to 3. So you first integrate with respect to z. You first integrate with respect to z. So this will be 4z square upon 2, that is 2z square, and let's first integrate this one, 3z, then you have xz square, so it will be xz cube upon 3, and the limits will be, limit of z will be x square y square to 3. So if I put the limit, this will be equal to double integral twice, this is 9 minus x square y square, then 3 into 3 minus x square y square plus, this will be x, and the limits are, I'll change the color, let me rub this portion, so it will be x upon 3, this is 27 minus x square y square dx dy. Alright, now what is the limit of x? See, I will separate it first. This becomes 18 minus 2x square y square, 9 minus 3x square y square dx dy, and this is x upon 3, 27 minus 3 by 2 dx dy. First of all, what is the limit of this double integral? The limit of double integral will be the projection of this whole cone on xy plane. So what is the projection of the whole cone on the xy plane? It will be a disk of radius, you can put z equals to 3 over here, so it is disk of radius 3. Let me draw that. If I take projection of this cone it will be a disk of radius 3. It will be a disk of radius 3. So let me draw the disk. It will be of this kind. If I take this as axis, it will be a disk of radius 3. X and y, this will be x square plus y square equals to 9. So limit of x, if I draw an arrow in x direction, then x will vary from under root 9 minus y square to plus 9 minus y square. So you see this. Earlier also we had this kind of thing. This is an odd function of x, and the limits are of the format minus a to plus a. So this integral will go to 0. As you know, minus a to plus a fx dx is 0 if fx is an odd function, and we can evaluate this integral. We'll convert it to polar coordinates. Since we have to evaluate it over this disk, so let's convert it to polar coordinate, which will come 18 and 9 is 27, and this is 2r square, and this will be minus 3r r dr d theta, So we have to now evaluate this integral. We'll evaluate this integral. So let us evaluate this integral. I'll rub this portion. So let's evaluate this. This integral comes out to be 27r minus 2r cube minus 3r square dr d theta, and for this region r varies from 0 to 3 and this varies from 0 to 2 pi. So it is 0 to 2 pi. Integration of r is 27 r square by 2, 2r4 by 4 and 3r cube by 3, and the limits are 0 to 3. So this comes out to be 54. It will, if you calculate it, it comes out to be 54 and 0 to pi d theta. So total it will come out to be 108 pi. This will be the answer you'll get. So the surface integral over the given region is 108 pi.